Welcome to the 5.7 notes, function operations. I think this will be probably one of your favorite sections we've done recently. It's a little bit more straightforward. So basically, a function operation combines two functions using an operation to make a new function. So the whole goal is that we're combining them to make a new one. So you can add, subtract, multiply, divide, or do something called composition. And composition will probably be the trickiest one for you. I'm just going to kind of use these two functions up here at the top to do each one. And I do want to kind of point out a couple of things about the notation. You'll notice that this is f plus g of x, and this is f of x minus g of x. You can either write it together like this or separate like this for plus or minus, it doesn't matter. And really what you're doing here is you are combining like terms. And then I do have one other hint for you, and that is if you are subtracting, then you're going to want to distribute the negative. Okay, and I'll show you what that looks like when we get to the subtraction problem. So for example, here, I'm going to go ahead and write f of x and g of x. So f of x is x plus 3, and g of x is x squared minus 9. And you just want to add together any pieces that you can, and then make sure you write it with highest exponents first. So for example, the x squared doesn't have anything to add to, so it's just going to come right here in front. And then you're going to put the plus x next. And the only thing you can really do on this is add the 3 and the negative 9. And 3 minus 9 is negative 6. And this is your new function f plus g of x. That's really all we're doing here. And then for subtracting, be careful with the order. It wants you to take f of x first. So f of x is x plus 3 minus g of x, which is x squared minus 9. And I'm putting that in parentheses because what I need to do is take that negative and distribute it to both of these, because otherwise you're probably going to forget that you're subtracting negative 9 at the end. And that negative and the negative 9 make a positive. So then I'm doing the same thing as I did on the one up above, except for my signs are a little bit different this time. So the x squared is now negative x squared. The x is still positive, and now I have 3 plus 9, which is 12. Okay, and that's really the only difference between adding and subtracting. Now we're going to talk about multiplying. Multiplying we've been doing for a little while now. I'm going to write a reminder up here that says FOIL or box method. It doesn't matter which one you pick. Order does not matter on this one either. So here we have f times g of x. So I'm going to multiply the two of them together. Here's f times, here's g. And I have to multiply these together or distribute now. And that's why I said FOIL, so that you can multiply firsts. X times x squared is x cubed. Lasts, x times negative 9 is negative 9x. Insides, 3 times x squared is 3x squared. And lasts. I think I already said lasts, so I should have said outsides. Sorry. So first one of each parentheses, outsides, insides, lasts. First is the first two. Outside is the outsides. Inside is the inside. And lasts is the last one in each parentheses. If that helps you keep track of it so you don't forget, There's no like terms on this one. However, I do want to make sure that I write the 3x squared before the negative 9x so that it is in the correct order. And there you go. Now, let's talk about dividing. When you are dividing, it's going to make a fraction, and what you're going to need to do is simplify by factoring. So, for example, this one is f divided by g, so f of x gets to go on top, and g of x gets to go on the bottom. And then before you say that this is your final answer, you have to factor each expression. X plus 3 can't get factored anymore, so it's going to stay the same. But x squared minus 9 is a difference of squares. You can also think of it as there's 0x here in the middle. So you need two numbers that multiply to negative 9 and add to 0, which would be 3 and negative 3. It's also just doing the square root of x squared and 9. One with a plus and one with a minus. So then here's what happens. You have an x plus 3 on the top and the bottom. You get to cross those out because they are common factors. And that leaves you with an x minus 3 on the bottom. And this part does get just a little bit tricky for a second because there's nothing left on the top. So you have to leave a 1 up there. And that is your final answer. Almost all of the time when I give you an example, something will cross out like that. Doesn't have to, but a lot of times it will. And now we get to something called composition. Composition is the process of plugging one function into another. Which is really just a fancy way of saying substitution. Okay, so it's really plugging one function into the other using substitution. And we're going to do this both ways. So what you'll notice here is this looks a lot like the multiplication, but it's an open circle. That means that you're going to plug g into f of x. Okay, so whichever one is on the inside gets plugged into the other one. So it's like saying, hey, go replace all of the x's in f of x with whatever g of x is. So if f of x is x plus 3, what you're going to do is take the x and replace it with g of x, which is x squared minus 9. So we're plugging g into f, wherever there is an x. Whichever one is on the outside is like the original structure, and then you take the x and replace it with whatever the other function was. So if I come down here to the next one, this is plugging f of x into g of x. So you start with the structure from g of x, and you replace the x with x plus 3. And then I'm going to go ahead and finish simplifying both of these. This one up here, the parentheses aren't really there for a reason. We can just add together these two. So it's actually x squared minus 6. And down here, hopefully you're starting to get used to the fact that x plus 3 squared does not just mean you square both of them. It means you have to do x plus 3 times x plus 3, which is going to be x squared plus 3x plus 3x plus 9. And then there's this minus 9 here at the end. And then we're going to combine like terms. So over here, this whole process is just me distributing this out. And I know I went through that a little bit faster. If you're having trouble multiplying polynomials like this, please just have me do a couple with you. These two in the middle add to 6x, so I have x squared plus 6x. And then at the end, the 9 from me multiplying this out and the negative 9 that was already at the end cancel, and that's my final answer right there. So sometimes the simplification is a little more annoying than other times. That's going to happen in math in general. Sometimes simplifying becomes really lengthy, sometimes it's really short. That's the part that gets a little bit tricky. And then just to do some extra examples, I'm going to come down here to example 2. And I'm going to use the same type of thing, not quite as many times. So here I have f of x plus g of x. Notice the difference between this and this. It's really asking you to do the same thing. It can just either be written together or separate. Okay, so this time, I'm not going to show my work this time, guys. I'm just going to say there's an x squared here, but not over here. So that's just going to stay x squared. And then I have 4x plus 1x from g of x. That makes 5x. And then I have negative 5 plus negative 1. So you're just combining like terms. You don't have to write it out the same way I did up there. It honestly just takes longer and you don't really need it. The time you do need it, though, is when you're subtracting. So I'm going to go ahead and write f of x. And then when I write g of x, I'm going to multiply it by this negative. So negative x is negative x. Negative 1 becomes positive 1. And then you add your x's together. Again, if you need to put a 1 in front of this to help you out, go for it. 4x plus negative 1x is 3x. Negative 5 plus 1 is negative 4. And don't forget about the x squared. That's just kind of chilling out front, as some of you have called it. And I should have blocked my answer over here. That was the end. Then you'll notice there's a number. That just means that either you're going to do this and subtract them, and I can plug in the number 3 over here, which is one way of doing it, or you can do this, f of 3 minus g of 3. Because like I said, you can either write it separate or together. This just means you plug in 3 into f of x. So let's see, that would be 3 squared, which is 9, plus 4 times 3, which is 12, minus 5. G of 3 would be 3 minus 1, which is 2. So this would be 21 minus 5 is 16. This one was 2, and we are subtracting them. So we should have an answer of 14. Basically, you just find f of 3 and g of 3, and you subtract your two answers. Or if you've already done this over here, you can just take 3 and plug it into this, and it should give you the same answer. So that would be 9. I'm kind of wondering if I made a mistake. Anybody, let's see, 9 minus 9 minus 4. Oh, that's a plus. There we go. There we go. 18 minus 4, same thing. Hey, you get it either way. I just made a little sign error when I was copying it over. Okay, and then this is where it gets to be a little bit easier. So instead of multiplying this out using FOIL like I did in this one right here, if it gives you a number in the parentheses, that just means find f of 2, get an answer, and multiply it by g of 2. Okay, so for f of 2, that'll be 2 squared plus 4 times 2 minus 5. I'm just plugging 2 in for these x's. And g of 2 will be 2 minus 1, which is really nice because that means whatever I get over here, 2 minus 1 is just 1. So you're just multiplying it by 1. So let's see, this is going to be 4 plus 8 minus 5. 12 minus 5 is 7. Okay, and I'm going to pause right here to go back and say, if there is an x in parentheses, there should be an x in your answer. If there is a number in parentheses, your answer should be a number. Okay, E wants us to divide them with f of x on top, x squared plus 4x minus 5. And g of x on the bottom, just remember you want to try factoring the top. The bottom can't be factored at all because it's already just x minus 1. So two numbers that multiply to negative 5 and add to 4 is positive 5 and negative 1. Keep the bottom the same because we're not really changing anything there. We're just factoring. And then you do have an x minus 1 on top and bottom, so that means your answer here is just x plus 5. Boom. And then we get into the compositions, which can be kind of tricky. F of x is on the inside. So that means you want to start with g of x, and then take the value, or take the place wherever x is, and replace it with f. So I'm just taking x and replacing it with f of x. That's really all a composition does. It's like a substitution. If it helps you to see it in parentheses like this, that's fine too. But all I'm going to do now is add my like terms. And negative 5 plus negative 1 is negative 6. Then g is asking me to do it, but the opposite way. So take g and plug it into f. Now, you will notice in f of x, there are two different x's. I have to replace both of them, guys. So this one has to become x minus 1, and this one has to become x minus 1. Which, again, means that simplifying is going to be a little more annoying on this one. When you do x minus 1 squared, that's x minus 1 times x minus 1, which is going to be x squared, negative 1x, negative 1x, positive 1. And then I'm going to multiply this 4 to make 4x minus 4. And then the minus 5 is still there at the end. Okay, so it's a little bit more annoying. Now I get to add together my x squareds. There's only one of them. If there are a lot of terms, you can cross it out as you go. And then I have negative 1 plus negative 1 plus 4. Those are all of my x's. So negative 1 plus negative 1 is negative 2. And negative 2 plus 4 is positive 2x. And then 1 minus 4 is negative 3. Negative 3 minus 5 is negative 8. And there you go. Survived it. H is my favorite because it looks so complicated, but all you have to do is start with this middle piece. Go find f of 5. Okay, so here's f. All I do is plug in 5. Okay, that'll be 25 plus 20 minus 5. 25 plus 20 is 45. 45 minus 5 is 40. And then you're going to take that answer and plug it into g. And g is just x minus 1. So x is now 40 minus 1 is 39. So on these, you start with whatever's on the middle. solve it, take this answer, and plug it back into the other one. Okay, one last thing is you will notice it matters what order you do this in. These were not the same answer. They're only the same thing in a rare case called inverses. Order does matter. Inverses is going to be 5.8.